Something is wrong, and this time it is the silence that is most terrifying. For decades, the Solfatara crater was never quiet. Steam rising, toxic gases escaping, mud boiling beneath the surface that was normal. That was how the Earth released pressure little by little every single day. But right now, everything has stopped. No steam, no gas, no visible release, just silence. The scientists monitoring this system are not celebrating. They are not calling this stability. They are watching and waiting. Because in geology, when an active system suddenly goes quiet, it is rarely resting. It is changing often in ways that are far more dangerous. Think of it like a pressure cooker. As long as steam is escaping, everything feels under control. But the moment that valve gets blocked, the heat does not stop. The pressure does not disappear. It builds unseen, unnoticed until something gives. And that is exactly what may be happening beneath Campi Flegrei right now. Beneath a region where nearly 3 million people live, the signals are shifting. The surface looks calm, but underneath something is building slowly, silently, and without warning. Stay informed with the latest developments on this story by subscribing to the channel and turning on notifications so you never miss what happens next. Campi Flegrei is not a distant, isolated volcano. It is a vast volcanic system stretching roughly 13 kilometers across, located just west of Naples in southern Italy. Unlike the classic cone-shaped volcano, most people imagine this is a caldera, a massive collapsed structure hiding multiple photong zones beneath the surface. And above it, life goes on. Nearly 3 million people live within what scientists define as the potential impact zone. Cities like Naples and Pozzuoli are built directly on top of this system. Streets are crowded, homes are tightly packed, and daily life continues as if the ground beneath is stable. But it is not. Solfatara, one of the most active vents in this entire caldera, has long been a visible reminder of what lies below. For years, it constantly released steam and gas, acting like a natural pressure valve for the system underneath. Tourists visited, locals passed by. It became part of the landscape, something dangerous yet familiar, now that familiarity is gone. Because when a place known for constant activity suddenly goes quiet, it forces a different question, not whether something is happening, but what has changed beneath the surface. And right now, beneath Campi Flegrei, the answer is becoming harder to ignore. What makes this moment different is not what people can see, but what they can no longer see. For decades, Solfatara functioned like a living system. Steam vents hissed continuously, gases escaped through fractures, and the ground released pressure in a steady, visible way. It was unstable, yes, but it was also predictable. Now that pattern has changed. Surface readings show a sharp drop in gas emissions. The vents that once released constant streams of vapor are weakening, in some areas nearly silent. At first glance, that might seem like a sign of improvement. Less gas, less activity, less danger. But the data tells a very different story. Because the gas has not disappeared, it is still being produced deep below the surface. Carbon dioxide and sulfur dioxide levels underground are rising, not falling. The only difference is that these gases are no longer escaping the way they used to. They are being trapped. Scientists believe mineral deposits, layers of sulfur, silica, and other materials, are gradually sealing the pathways that once allowed pressure to release. Over time, these deposits build up, narrowing the vents until they become partially or even completely blocked. And when that happens, the system does not calm down, it compresses. This is the critical shift. A system that once released energy openly is now holding it inside. And in volcanic systems, trapped energy does not stay stable. It accumulates, changes behavior, and begins to search for a new path. The question is no longer whether pressure exists. The question is where and when it will finally break through. What scientists are seeing now is not based on speculation, it is coming directly from instruments embedded across the Campi Flegrei system. At the surface, gas emissions appear to be declining. But underground, the data reveals the opposite trend. Measurements of carbon dioxide and sulfur dioxide are rising to levels not seen in recent years. This confirms a critical point. The gas is not disappearing, it is being trapped beneath the surface. At the same time, the ground itself is moving. In Pozzuoli, the city sitting directly above the most active part of the caldera, the Al-Ard has risen by nearly 10 centimeters in a single month. That is not a slow geological shift. That is rapid deformation, a clear sign that pressure is building below. Seismic activity is also intensifying in a very specific way. Over the first months of 2026, more than 200 small earthquakes were recorded beneath the Solfatara area. Individually, they are minor, but together they form a pattern, and that pattern matters. The earthquakes are becoming shallower over time. Their origin is moving closer to the surface, suggesting that the source of pressure, whether gas, fluid, or magma, is migrating upward through the crust. This combination of signals is what concerns scientists the most. Rising gas levels below, decreasing release above ground, uplift and upward moving seismic activity all pointing in the same direction, not randomness, but a system under stress reorganizing itself beneath the surface. To understand why this moment feels different, scientists are looking back at the last major crisis in Campi Flegrei, the unrest of 1984. At that time, the ground was rising, earthquakes were increasing, and the entire region was under pressure. Thousands of residents were evacuated as a precaution. But despite the intensity of those signals, one key factor remained in place. The system was still releasing pressure. Gas continued to escape through vents like Solfatara, allowing part of that internal energy to dissipate. It was unstable, but it was not sealed. Today, that condition has changed. Now, the same warning signs are appearing again. Ground deformation, increasing seismic activity, rising gas concentrations underground. But this time, the surface pathways that once allowed pressure to release are no longer behaving the same way. They are restricted. And that difference changes everything. There is a term volcanologists use to describe this type of scenario. It is rarely mentioned in public discussions, but it appears in technical analysis and internal assessments. Runaway pressurization. It describes a state where pressure inside a volcanic system builds faster than it can be released. Once that threshold is crossed, the system no longer stabilizes on its own. It accelerates. This is not a gradual process. It is non-linear. Small changes can lead to sudden shifts, and the timing becomes increasingly unpredictable. That is why scientists are paying such close attention now. Not because an eruption is guaranteed, but because the system is approaching conditions where control, prediction, and early warning become far more difficult. What makes a sealed system so concerning is not just the pressure itself, but how that pressure is released. In most volcanic settings, warning signs unfold over time. Gas escapes gradually, the ground cracks. Seismic signals increase in a way that allows scientists to track the evolution of the system. There is movement, noise, and visible change signals that can be monitored and to some extent interpreted, but a restricted system behaves differently. When gas and heat are trapped beneath a sealed surface, pressure does not dissipate in stages, it accumulates. And instead of multiple small releases, the system may hold that energy until a single fracture forms in the wrong place. At that point, everything can change very quickly. History offers a clear example in this same region. In 1538, an eruption occurred that created an entirely new volcanic cone within a matter of days. Reports from that time describe the ground opening suddenly, with little meaningful warning before the event escalated. That eruption was relatively small compared to the full potential of the Campi Flegrei system. Today, scientists are not saying that the same outcome will happen again, but they are observing conditions that could lead to rapid transitions from apparent stability to sudden activity. In a system where pressure is contained, timing becomes the most uncertain factor. It may build for weeks, months, or longer. But once a critical point is reached, the release is no longer gradual, it is immediate. For the people living above Campi Flegrei, this is not just a scientific situation, it is a daily reality. In cities like Pozzuoli, the changes are no longer abstract. They are visible, physical, and impossible to ignore. Walls that were once solid now show cracks that return even after repairs. Floors tilt slightly, doors no longer close the way they used to. These are small shifts, but they are happening more often. And they are happening without a clear end. In some neighborhoods, residents have reported ceilings collapsing without a major earthquake, not because of a single violent event, but because the ground beneath their homes is slowly, continuously deforming. The land is rising centimeter by centimeter, pushing against the structures built on top of it. This gradual movement is known as bradycism. It has affected this region before, but the current phase feels different in its intensity and consistency. Behind every data point is a person trying to live a normal life. Imagine someone who has spent their entire life in the same apartment. Their family lived there before them. Their memories are tied to that place. Leaving is not a simple decision. It means abandoning stability, history, and community, so they stay. Not because the risk is invisible, but because it is uncertain. Because no one has told them to leave, and because human nature tends to delay action when the danger does not have a clear timeline. For many, the ground may be changing, but life continues above it one day at a time. If the risk beneath Campi Flegrei continues to escalate, the next question is not just what might happen, but how people would respond. On paper, there is an evacuation plan. Italy has developed a national strategy outlining how residents in the high-risk zone would be relocated in the event of a volcanic emergency. The plan is detailed, structured, and regularly updated. It assumes that authorities would have enough time to issue warnings, organize transport, and move large populations out of danger. But that assumption depends on one critical factor: time. And time is exactly what a sealed pressurizing system may not provide. Current estimates suggest it would take at least 72 hours to evacuate the most vulnerable areas safely. That includes coordinating transportation, managing traffic flow, and ensuring access to critical services. Under normal conditions, the road network already struggles with congestion. During peak travel periods, traffic can come to a complete standstill. Now imagine that same system under emergency conditions. Hundreds of thousands of vehicles attempting to leave at once, limited routes, bottlenecks forming within minutes, delays multiplying as pressure builds beneath the ground. The challenge is not a lack of planning, it is the gap between planning and execution. In a scenario where warning time is short or uncertain, even the most detailed evacuation strategy may face limits that cannot be easily overcome. Solfatara is only one vent within a much larger system. Campi Flegrei spans roughly 13 kilometers, with multiple nacats showing signs of change beneath the surface. Recent thermal data suggests that activity is not isolated. Other areas within the caldera are beginning to exhibit similar patterns: rising heat, shifting gases, and subtle deformation. This raises a critical possibility. What is happening may not be limited to a single blocked vent. It could be a broader system-wide response, where pressure is building across multiple nacats at the same time. If that is the case, the scale of what follows becomes far more complex. Campi Flegrei is not just a local hazard. In past events, eruptions from this region have had wider environmental impacts, affecting air quality, climate conditions, and agricultural systems beyond Italy itself. While no one can say with certainty what will happen next, the uncertainty is exactly what makes this situation so closely monitored. Right now, the signals are clear: reduced surface release, increased underground activity, rising ground, and a population living directly above it all. No confirmed timeline, no precise prediction, only a system that is changing, and a question that remains open. If the pressure continues to build, what happens next? Stay updated with the latest developments on Campi Flegrei and other global events by subscribing to the channel. Turn on notifications so you never miss critical updates. New insights, real data, and breaking changes are coming. Stay informed and be ready for what happens next.